some coding practice to learn more about aggregate functions. We're going to be taking a group of values and getting one summary value from that data. Let's look at the vArt database. And let's just, before we get into the summaries, let's just do a simple query where we want to get the country, the first and last name from the artist table. Here we get all the artists. We don't have any filters or where clauses, so everybody is showing up. Now, our database is very small, so there aren't many artists here, but it is everyone that we have in the database. Let's go ahead and add a filter where we say we just want those from France. Now we're getting just those from France. So far we haven't summarized anything yet. We've just filtered. But what if we wanted to know how many artists were from France? Well, that's easy in our case, right? We just add them up. There's 2. But what if our data had thousands or millions of rows of artists? Our query wouldn't be very efficient because we'd have to manually count all of those rows ourselves. That's where aggregate functions come in. One of those functions is the count function. Let's add that function to country. We want to count by country all those that are in France. Now I'm going to take off the last and first name for now, and I'll explain why here in just a minute. We run that. We now can see that we get one row of summary data from multiple rows. Now we only had 2 rows, but we did get one value from multiple rows. So if we had 100 artists from France, we'd now see a result set that had one value of 100 here. So with the aggregate function, we quickly can see how many are from France using this count aggregate function. So why couldn't we have left the first and last name up here? So we get an error. It's because we have summarized a number of rows into one row. So now the first and last name don't really go with they do go with each individual artist, but they don't belong with a summarized value. How can we show in that one row both Monet and Van Gogh there with that same one number? So for that matter, what if we had 100 different artists from France? If that's how many we had from France, then we can't show that with just one value, and that's what we're getting back. We could put the country in here though, because that value is the same for the aggregate function. They all have that in common. Because we counted the country or France, we can use that column name. Let's go ahead now and look at the bike database. And let's do another simple query. Select the list price from the product table. So getting the prices of all the bikes. And that will give us all the prices. So let's go ahead and let's try an average instead of count this time. So that's the AVG aggregate function. Now what's going to happen here is we're going to take every single bike price that we just saw, and we're getting the average of all of those bike prices. So we're taking a group of data and we're getting one summary value from it. Now with this math that's been done on the numbers, we're getting a very large decimal place. So we can use a scalar function with the results of the aggregate function to get the decimal places according to currency. So the scalar function, such as format, can be used with the aggregate function that works on the group, and this can then take that one group return value and say I want it to have 2 decimal places, and it can be used with the aggregate if I didn't type it out wrong for format. Okay, there you go. Let's try another aggregate function, sum. Sum will add up all the prices from, and some won't need format because the decimal places are not the same. Okay, so sum is going to add up all the prices from the list of data. Instead of getting an average, we're getting just a big total of all of them. No extra decimals were created with this aggregate function, so we don't need the format function here. Let's try a few more aggregate functions. Let's get the largest and the smallest bike price with max and min. So we can say the max list price and the min list price. Now we have not only the sum in the first column, we have the max, the most expensive bike, and then the least expensive bike. What if I wanted the average of each model year? I want to know the averages from year to year and what that looks like with our bike prices. So I could try something like this. Let's just come down and do a new one. And we'll come back and we want the average of each year. So you could do something like this. You could say, I want to filter where the model year equal to one of those years that I want to look at. I could run the query and get the average for that year. And again, I probably want to format it so the decimal places were done properly. But what if I have 50 years worth of bike data? How could I, instead of going through and changing it from year to year to year, how can I speed this up and get them all at once? Okay, so this is where the group by clause comes in. So now we're going to add a group by clause. So if I come in here and I say group by the model year, we'll add that group by keyword, and it's going to group the data before we run the aggregate function. So the aggregate function is still working on multiple values and summarizing, but before that's done, the data is going to get grouped in different ways. In our case, by the model year. So here we want to group all the bikes by year before we run the average of those prices, so that we can get that average price for each year, and not all of them together. So we run that, we'll see we had 4 different years because we're getting 4 different rows. We can add the model year column, clarify that just a little bit. And it's okay to add that model year to the select because each model year really does go with each of those rows. So each year will belong to one row, so there's no problem adding it there. All right, so now we can see that we can get the average of each bike by what model year they fall into. Aggregate functions can be very powerful and very useful. It can get a little tricky, however, when it comes to filtering our results. We can now filter before we group or after we group. I'm going to add a where clause to this to filter it just a bit so we can visualize this with a few less rows. So basically we're going to limit it down to just the bikes that are more expensive than $2,800. Okay, so now we get just the bikes, and this average went up because now we're just looking at the bikes that are over 2,800. So this ran first, and it eliminated a lot of those cheaper bikes. Then it was grouped. That's why the prices are a little bigger here. Then those groups individually got averaged. So let's just look and see what exactly is going on here. So I've got a image here, and it's kind of hard to see, but basically we have a list here. I don't want to zoom in too much. Okay, we have a list here on the left. That's the first thing that's going to happen. The middle one's the second thing that's going to happen, and the last column is the last thing that's going to happen. Oops, I'm twisting it. Okay, so if we look at our order of execution, we'll see the first thing that runs is this part of the query. It's going to the product table and it's filtering out every bike that is less than $2,800 and only wants those that are above that price. So this first column here is what's resulting from the from and the where. Then the group by is going to run. And it's going to take this whole result set and it's going to group it by year numbers. So this middle column is what's happening with group by. This first group is the year 2016. The second group is the year 2017. Third group, 2018. And fourth group, down here at the bottom, 2019. Then lastly, the select statement with the aggregate function is going to run. And that is represented by this last column here. Takes the first group, averages those three amounts, and puts it here in one row. One row for this group of data. The second year, 2017, is grouped, and it's going to get the average from that and give it one row with the average amount. Same for 2018. All of those bikes get averaged, and it gets its own row. And the two bikes from 2019 get averaged, and they get their own row. And because we only had 4 years on our database, that's why we have 4 rows showing up. Okay, so hopefully that helped kind of visualize what's going on here. So the order of execution runs from and where first, getting all the products that cost more than $2,800. Then we would get a group of data for each of those years that are listed in the group by, or referred to in the group by. And then the select runs and we get the model year. And at this point, we know that all the model years are in the same group, and we're going to get an average of each of those groups. So we have a row for each year, because that's how we grouped it. All right, let's introduce at this point the roll-up with roll-up clause. It is a subclause of group by, so it works with group by. And if we run that, you'll see we'll get an extra little row at the bottom. So what roll-up's doing is it's going to take the group of aggregates and aggregate them. So it's taking a summary of the summary rows. Now we can see the average of all the averages. I like to use it with sum, so adding them all up. So now, when I use it that way, make sure I actually run that. Okay, come on. There we go. Now we're adding up all the prices of the bikes that are over $2,800 for each year. Then we're getting a row that sums up all the sums at the bottom. Or in other words, like a grand total of the totals of each year. Okay, now another keyword. Let's look at the keyword distinct with aggregates. We've used distinct before when we wanted to only see unique results. We can also use it with aggregate functions as well. Let's put average back on the list price. Okay, and then, let's see. Sorry, I had to get my charging cord. I have to find where I'm at now. All right, and then we're going to add the distinct keyword right here. Now, if there are list prices that are exactly the same, they will only be included in the average one time. So with this, we're going to be saying, if you find a bike with the exact same price of another bike in that model year, just count it once in the average calculations. So if there were 2 bikes that were $99 that 99 would only be averaged in one time. And you'll see it is a little different from without distinct. There are bikes that have the same price. All right. Now the default we've been using is the all keyword. And we haven't been typing it because it is the default. It's assumed when you run any aggregate function, it's going to add all of the values. But it does run exactly the same if you use without using all. Okay. Distinct works really good with count. I'm going to put distinct back on here. And I'm going to put count here. And we'll run that, and we'll see we get 3, 7, 12, 2, 16. If I take off the distinct and put the keyword all, we get a few different numbers in some of the years. Okay, because we've got some prices that are the same. Remember, this is the same as just leaving it off. But I did want to point that out in case you see the word all at a certain time. All right. Let's see. Okay, we're going to do one more new clause, and that's the having clause. Remember, I said you could filter before or after, and we haven't done the filtering after the grouping yet. So that's the having clause. The having clause is also a filter. It's just like where is, but it's going to filter after the groups have been made. So you can filter before the groups with where, and after the grouping with the having clause. So we'll leave the before one, and we'll also put a filter after having, and then we can actually use the same aggregate over 4,000. Okay, so now we see we don't see 2016 anymore. We don't see through 2018 because their averages were not over 4,000. So they were eliminated out of our result set. Let's look at that picture again just to see what happened here. So we've gotten to this point because having comes after group by and after the select actually runs as well. So the having looked at these four and it said, oh, these are the only two, 2017 and 2018, that were over $4,000. 2016's under, and so is 2019. So that left us with two rows that were over that amount. So that having is at the very end after they've already been aggregated, or in this area here where that's going to actually filter. Okay, the having clause is limited to only using the columns as the condition to what's in the select statement. In fact, let me make sure, I should have changed this to average. Okay. All right. The having, let's see, the where can filter by any column in the table, because at that point in the order of execution, you can see all of the different columns. But at this point, you're pretty much limited to just what was in those summary rows. So you're limited to compare at that point with just what's in the summary rows. So that will kind of help you remember what can be used where. I cannot use an aggregate here. I couldn't say average list price and where, because at this point when the from and the where run, we haven't even gotten to this yet. But I can use a column that's not even in group by or having at all and still use where, just like we've done in the past. So remember those little things there when you're using where and having. All right, we can make our average number again look a little better if we go ahead and throw in format here like we did before. And again, that will change there. But remember, I've had students do this. They've said, okay, I can use anything in the select in my having clause. I can use that same aggregate here, and throw it in there. And they get no results back at all. That's because the format changes the data type of the decimal to a string because it's got that comma in there that we put, at every thousandth spot. So when you compare a string, this area, to a number, that you get no results because they don't compare. Strings and numbers don't compare. So if you just would need to take the format out of that at this point, it'll still result back as a number that can then be compared if I type it right. Ready? All right. Okay, remember the having clause can only use this list in the select statement because those are the values or address that are part of the grouping. But the where clause can refer to any column in the base table, even if it's not listed in the select. So here we can filter where by product name, even if it's not even in the select, we could do that. So be aware of that as well. So you could say something like where product name was like, and then it has the word speed in it somewhere. So we'll just say speed. And it's not getting me anything. Oh, because there's none that are that big. So let's bring that down to 300. There we go. Okay. So remember, we can use product name here, even though it's not even in any select, because it's before we have limited down to only these two columns. This one is at the very end, so we're pretty much limited to what's inside the select here. All right, what if I wanted to get the average of each brand? So you want to see the brand name and then have the average price of all those bikes for each brand. You can pause the video at this point if you want to see if you can do it by yourself, but just a hint here, you're going to be joining the brand and the product table together first and also doing an aggregate with a group. All right, so you paused. Hopefully you've got it close, but let's go over and see how I would have done it. So I would have had the brand name, and I would have grabbed the average list price. Whoops. And I would have grabbed those from the product table because that's where the list price comes from, but the brand name comes from the join from the brand table, and what connects those two together is the brand ID. And we can throw in some table aliases here really fast. And oops. Okay, then we're going to group it by the brand name. And I'm going to throw in a with roll up just for fun. We don't have to, but I want to see what that looks like. All right. So now we can see the average per brand name, which is super cool. All right, let's try one that includes a where and a having together. So we want a result set that shows the brand name and the average list price for each of those brand names like we have here. But we don't want to include any 2006 model year bikes even in this average at all. And then we also want to only see average list price values of over 2,000. Okay, so we don't even want to include any year 2016 in our averages at all. So that's going to actually go in the where clause before we even do the aggregate. Okay. And then we want to only see the average list price of values over 2,000. So we're going to say list price Whoops, maybe having. We want to compare the averages. We do need to say average list price greater than 2,000. But then we only get Heller and Trek have an average that goes that high. Okay, so as I'm doing, it's probably a really good idea to kind of put what each of these is doing. So we're getting the average of each brand list price. Only, well, I could say with no 2016 and only averages over all right, because they're getting a little longer, so I want to make sure I comment and know exactly what I'm doing here. All right, let's practice a little bit with the magazine table. All right, let's find out how many people subscribe to the Beautiful Birds magazine. And again, you can pause it and try this out on your own if you want. And I'm going to quickly quit how I'm going to do it. So pause if you don't want to see. Okay, and we have, hold on. Okay, so this is what I came up with to find out how many people subscribe to the Beautiful Birds magazine. So we'll see that 2 people subscribe to that magazine. We went ahead and just counted everybody, so, or in other words, every ID of subscribers from the subscribers or from the subscription table. And we also used the magazine name here in the where, so we had to include that table as well. In fact, we didn't even need table aliases. Primary foreign key are different on this one, so we're probably good to go. All right, so let's do another thing here. Let's add the magazine name to the select. Run that, and you can see now which you can have the magazine to kind of clarify which one we're talking about here. All right, what if we want to how many subscribers to each magazine, not just Beautiful Birds? We could say something like group by magazine. And again, we're good with the magazine name being up in the select still because that's what we grouped it by. You can see that. Now, again, we could filter it after we grouped it by saying, okay, I only want to see the magazines having 2 or more subscribers. So we could say having subscribers greater than or equal to 2. And then I'm actually using this word subscribers from this alias here. So I could put count ID here as well, and it would be the same thing. Now we can see that we'll get only those that are over or equal to 2. Okay. I'm able to use this alias here because having is very last after the select runs. It's already seen the alias, and you can see here. But again, I could have put count ID, and it would have run the same way. A few more practices on the bike database. And we're going to go ahead and, oh, I wanted to show this one too. So we could also do a total revenue for each bike or each magazine. So before we run bike, let me that back off and actually run magazine again really fast. I'm going to show this one. So basically we're adding this sum of magazine price here. If we wanted to get like the average, and I did take back off the halving, but I did add a order by. You can see here, you can get how much revenue. So 2 times the price for this one, 3 times the price for this one, and so forth. Okay, back to bike. All right, so let's look at what these two are doing. We're getting the brand name and the highest and low prices of each bike of each of those brands. So now we're grouping it by band first, then we get the maximum minimum in that grouping. So now we can see what the highest and lowest prices are of each of those brands. Brand name and the price were in 2 different tables, therefore we have a join. Okay. We can also find out how many we have at each store. How many bikes do we have in stock at each of the stores? So first of all, we might want to just find out how many of the bikes we have. So if we run this one, we'll see we have over 13,000 bikes, and that's coming from our store table, our stock table, and our product table. So again, we didn't have to group all these right now, but we will here in a minute. So we group it by the product name. We can get a little more detailed information here. We can say group, by product name. And at this point, we would need all those tables because we're going from store to product. And we can now see all the different amounts here. Of course, I would want to put product up here so I could see what each of those went with. Product name. And then we can see how many of each of those bikes we have in stock. That's where we're using the quantity. That shows us what we have in stock. Now we can find out how many of not only each bike, but from each store, because each store had a different stock with it. So we can go in here and we can actually leave it by product name, but then also do a subgrouping of the store name within that. Now, if we come up here and we put the store name, you can see what's going on here. For Santa Cruz bikes, they have all these different bikes with this many different bikes at that store. If you scroll down, you'll eventually get to the next store, which is the Baldwin Bike Store, and it goes through all the same bikes and how many they have at their store. Okay, so again, you can have multiple groupings in here. We won't do it very often in this class, but be aware you do have that option as well. And if you reverse these two, you'll see it comes out a little different because one's your main group and one's your subgroup. And the main group was before by the product within each store. And now if we run this one, oops, I've got the product name twice. You can see I know what it was. It was with roll-up. That's what I wanted to show. Okay, so if we have with roll-up with this one, it's going to roll up at the end of each bike category. And again, I'm going to scroll down until we get to the end of Baldwin Bike. And we should have one row that will then sum up all the sums, the quantity, a total of all the quantity you have at Baldwin Bike. That's when if I reverse this, we'll see we get a different roll-up with this one. Now it rolls it up for every single bike. Every single product is the main one, so it gets a roll up for every single product instead of every single store. So it does work a little different depending on the order you have it, especially with the roll up. All right. Now, this is a real life example. We could easily see how many of one specific bike is at any of our stores just by adding a where clause here. So say a person comes in and they really want the Electra Cruiser One Lady bike, and you don't have it at your store, but you're going to check if it's at any of the other stores. So you might say where the product name, and it's kind of a long name, so I'll use light here. Electra Cruiser One Ladies. And what comes after that, so we'll just put it. And then if we run that, we can quickly see that it's not at any stores. Hold on. Let me make sure I wrote this out right. Electra Cruiser. Oh, I put 2. It's a 1. Okay, there we go. So now we can quickly see that Baldwin Bikes has 6. Maybe we were Rolette Bikes, so we didn't have any. And Santa Cruz Bikes has 4, and we have a total of 10 different bikes. And we had roll up within a roll up, so we get actually another column here. That's because we have 2 different columns here. But basically, we can quickly see which store has those different bikes that we need. So aggregate functions are pretty useful, and just have to kind of wrap your head around all the syntax and order and what you can use in each one. But they're really super detail specific and helpful to get just the information that you want, grouping up these data together to make sense.